Welcome to design session 4 of our really beautiful and awesome building that we're doing here with Blender, where I'm guiding you through the whole architectural design. All right, so in this version, unfortunately it's not going to be live, so apologies for that, but I just have some commitments to do. So it's pre-recorded, but hopefully you enjoy it just as much, and maybe it's going to be a little bit quicker and make sure the quality is guaranteed for you guys. So that's our building, right? So this is what we've got so far. We want to progress it a little bit further. So in the previous version of this, in the previous session, we were dealing with columns and we were drawing some pretty cool plans, right? So just rationalizing through the floor plan in terms of where the cores are and in terms of the column and grid layout. That's quite important for architecture to make sure that that works well. So we want to sort of continue with that now here and make sure that we lay out our columns. So we started in the previous one, we didn't finish it, but we're going to wrap it up now really, really quickly. So how are we going to do that? So we've got a couple of different ways. One is just using arrays for the modifiers. Not for the modifiers, for the columns. And then we also have some that are using a very basic geometry node setup where we have a line with vertices, and on every one of those vertices, we get a column. So if I extrude this and create another one, we get them and we get them and we get them. So it's a little bit more parametric, but at the same time, it gives us a little bit more flexibility in regards to exactly where we put our columns. So this is the way we're going to continue because we have a fairly tricky situation over here. So in this little instance, let me just get our node set up. We're just going to have columns that run like this. Yeah. And then column there, column here, and a column there. Let's give this a different color so you understand it. And that's it really. So the column grid is kind of irregular because we have the periphery here, which is our core, and then we have everything else. And then it's going to span in that direction. And then, yeah, there's going to be maybe a column here and here and a column there. So let's go ahead and do that now. So I'm going to turn off all the annotations. Let's make sure the screencast keys are on. And we've got a column here, which is okay. I'm just going to duplicate this. Actually, we're not even going to start with the columns, right? Because we're going to be dealing with a line. So I'm going to duplicate this line that we've already set ourselves up, and it's got the right angle, 15.5 degrees. So that's our project angle offset from the north. So in here, I'm going to go and delete all of these and dissolve them. So X and then D to dissolve, and then get rid of these vertices and then just stretch this one out to somewhere over here, and then this one to somewhere over here. And now we're going to create another one. And this one we're going to have to rotate. So the rotation requires a couple of steps in Blender to get it to be the right way. So first off, we want to click on the active element. Or rather, not even active element. We want to put the cursor here, so cursor to selected. Select this element, and we want to go in here where it says bounding box. So transform the pivot point, and there's a hotkey for that, which is the dot, and we want to use the 3D cursor. So now, if we rotate, you see how it rotates. Okay, and I think this is 22.5 degrees. So we can put whatever it is over there and then manually adjust this to 22.5 degrees. That's it. So that's pretty well set. And we want to do something similar over here. So extrude, put the cursor here, Shift S, cursor to selected, grab this element here and then rotate to something that's more or less correct to what we have over here. So this is 30.5 degrees. Okay, now let's drag these vertices out and put our pivot point back to median. So GG to just move them around, and then GG to move this around. And now let's extrude that, and that's just going to be like this. Now we're going to select these two vertices, and then TinyCAD. This is an add-on that comes with Blender, so you can go ahead and search for it. It's called TinyCAD Mesh Tools, and there's a very important command in there, which is a bit more CAD-like, and it allows us to create a vertex at the intersection. So now we have a vertex exactly at that intersection. So let's get rid of these two vertices. Let's try that again. Why is it doing that? We should have, okay, so for some reason it didn't do it. Let's try again. Maybe we should just do auto. Yep, that seemed to work. So now let's get rid of these two vertices. Cool, so we've got our 4 sides, and That's exactly what we want to make sure. Now this side over here, we want to use first off normal orientation. So that drags, but it gets a little bit tricky on the sides, right? This is not completely parametric, but at this point it might start to make sense. I'm just going to leave them as they are right now. I think the offset is more or less correct. So let's start subdividing these. And we want to subdivide them equally. We have a 7.5 meter general distance between the columns. However, in this case here, we're going to do something different, which is just right click and subdivide and change the number of subdivisions. So 1, 2, 3, 4. Something along these lines. So we have more or less the correct one. Maybe you do one more. So a little bit less is fine. Okay, that works pretty well. And we'll do the same here. So right click, subdivide, and change the number. Let's see how many we want. 4, 5. Why is it not changing? Let's try this again. Right click, subdivide, and we should be in... to see this better, we should be in vertex selection. So let's go into vertex selection, select these two vertices. Let's dissolve that one. Right click, subdivide. Yeah, I'm not sure why they're not coming through. That's strange. It's a bit odd. Let's get rid of these vertices here. Let's try this side. Maybe there's something wrong with that one. That one seems to work well. However, we cannot be in escape mode because we need to understand exactly where we put the bridge. So we don't want to have anything like this. So we need to move our bridge a little bit over so it aligns with those. So that's okay. We might have some kind of double situation here. Just trying to think. Yep, X, delete vertex. And that one is okay. There was an extra vertex in there. I think when we were doing the intersection, instead of separating the existing intersection, it did a brand new vertex over there. So now it should be good. Right click, subdivide, and yes, that seems to be working all right. And in fact, here you can already see how the bridge is aligning pretty much perfectly with our subdivision. Let's continue with this edge here. Right click. And you know what might make it easier to understand? Let's get rid of the other columns, because it's getting hard to understand which ones are which. There you go. That's a little bit better. So let's go back in here, right click, subdivide. And we just need 2 in there. So that's pretty good. And now we're going to need to create a couple of extra vertices in here. So I'm going to grab this vertex and go into local, and let's extrude it. 7.5 meters. And now I'm just debating. So that's 7.5 meters more or less. 7.5. That might be good because there would be a cross bracing here and a cross bracing there. So we actually just need one column. We might need another one over here because that distance, let's check what it is. This is about 9 meters, right? So that's 7.5, 10 meters. So yeah, we have a bit of an extra length over here, but I think that's not too much, to be honest, not something to be worried about. So yeah, great. We can just get away with just one column in here. Now let's do a similar thing here. Let's do a sanity check just to see distances. So that's 8.5 meters. That's 6.5. And it would be great to have here, but I don't really think it's needed because even that distance there, that's a fairly decent span. It's not terribly big. Anything below 9 is okay. The beams do get a little bit larger though. We won't worry about that level of detail in here. Great, so that's our grid in this point over here. And you can see here I've already started creating some kind of grid, and we'll need to do a similar situation where first off, this is an array. We need to erase these extra columns and create some more. So the easiest thing to do is grab one of these edges over here and put it right there. Now when we grab those, notice how we're getting the geometry nodes setup is coming through as well, which is great. That's exactly what we want. We can even keep this as one. We don't even need to separate this into a separate object. And now let's drag this all the way out and subdivide it. Right click, subdivide, and same thing. So I think we need 4. That should be a pretty good length. We can do a check here by enabling edge angle, not edge angle, edge length, 8.9. So that's a bit too much. Let's try then doing an extra one, subdivide. What is this distance? 7.13. That's better. And where else would we have these? So let's duplicate this edge here, rotate it 90 degrees. We'll put it somewhere over here along the edge and drag that out. And we're going to also subdivide this. Right click, subdivide into 2. That seems correct. Great. So we have our columns more or less aligned. We need to get rid of these columns here because they won't exist. That one also is a little bit tricky because it's very close to the edge, to the perimeter. And so what's the best way to get rid of these columns? So we can do like a boolean or even a raycast. Yeah, we can do a raycast that comes from our footprints. So whatever is inside the footprint over here is fine. Whatever is outside of the footprint, we get rid of. So that's going to be another geometry nodes setup. And we might even do it. Where do we want to do it? Yeah, let's do it on the column. So on the columns, we'll create a new geometry nodes and say filter, remove external columns. Okay, so we're going to use raycast, and raycast just checks if something is inside or not by pointing a beam at it. It's the best way to figure out whether it works or not because it allows us to keep everything still parametric instead of, and it's much lighter than booleans. Okay, so now it's a little bit tricky though because let's think. We don't want to use this bottom footprint. So that's the bottom floor, the ground floor, because just the level above, it steps out a little bit. However, some of these columns here, we do need to get rid of. So we might actually need to draw some kind of other shape manually to control exactly where we see the columns. And that's all right. We just drew something fairly simple and straightforward. So add our trusty little plane over here, and we can do it 2 ways. We can either draw a region around the area where we don't want the columns, or the opposite, the area where we do want the columns. Both are work. There's no real difference between the two. It might be easier to do it the other way. So let's see, we put it here, here. Let's do a loop cut. Yeah, that's good. So we're going to get rid of, yeah, that column should go as well. That's it. I'm going to use the same shape to get rid of columns on the other side as well. So let's duplicate this. And where do we have those extra columns here? Let's rotate this 90 degrees and put it somewhere over here. And now extrude. To get rid of those. Wait a minute. Okay, so that's the opposite, right? So we actually want to create a footprint around it. See, in this case, it's easier to do it on the outside, and here it's easier to do it on the inside because of the column layout. There's always positives and negatives in everything, isn't there? Or multiple ways to think about it. Okay, so let's create a really quick, rough footprint. It doesn't need to be exact. We're just looking to have columns that are either inside or outside in here. That should be good. Okay. So now let's go back to this layout over here, the one that overlaps, and we need to call this a name. And let's call this columns filter. Columns filter. Okay. Now let's select these in here again. Target geometry. We can just drag this out, object info, and say, if we just type filter, it should come in. And we want to use relative. We have to use relative. And now we check whether that geometry is inside or outside. And we separate it based on that. Separate geometry. Point is fine. And if it's hit, it stays. If it's not, it comes out. Why are these two in here? Oh yes, that's a different one. So columns, let's call this, nope, not this one. Oh, we already have a name, remove external columns. So we'll just apply the same geometry nodes to here. And let's find geometry nodes and select remove external columns. There, and that's done for us. So now if we go and, we say, let's create more columns. And you see they all appear once we move that. And it's super performative, right? Because it's doing very straightforward and simple calculation. Instead of doing heavier booleans, we're doing ray casting, which is shooting beams from every direction. Let's put these at 0, because for some reason they're not. We must have snapped there at some point. This is at 0, and these here need to be at 0. Are these at 0? Yep, they're at 0. Okay, column, grid, done. Now we can start to extrude those. And we have two sets of columns that are doing slightly different things, right? So here we have like a setup with the array, and then the perimeter ones, they're doing something slightly different. And that's okay, because we can handle both in the same way. So let's select first off the ones we did in geometry nodes, and all we need to do is extrude this mesh here, and it should be along the face. First off, let's fill it. So fill type, none. We can say hang on, that's fine. And then the scale determines how far the extrude. Let's try 30 meters. We might need to specify the offset. So combine X, Y, Z and say that it's going in the Y direction. A circle. Ah, okay. We didn't, for some reason, fill that in. We might not need that then. There you go. So now we've got these columns that are going up. How far do they need to go up? So a bit more. We'll filter them out once we need to with our base shape. So that's where we're going to start to do some booleans with our overall massing. So we've got our finished massing, but underneath of it, we do have a base massing, which is over here. So if we turn off the facade and we turn off the floors, you see our base massing. So that's going to determine exactly where our columns stop. Now, we have a couple of tricky situations with our setbacks, and we have to make sure that those setbacks more or less make sense with our column grid in a way where we don't have cantilevers that are too big. Yeah, so for example, here there should be a grid, like that should more or less align to a grid that makes sense. And it doesn't quite, right? Because the grid now is going in a different direction. So that might need quite a bit of tweaking to get it right. But that's the intent. So I'm not going to go and solve it completely in this case, but I just wanted to show you how we can think about it within Blender by doing this, which is, so we have this rational process, right? So we go in there, we create our first massing, we go back, we think about the grid, we come back out now to our massing, we see what kind of setbacks we have, and then we're like, okay, now we need to go and think a little bit more in more detail about the grid. And with these kinds of setbacks, we definitely have a structural team typically on board with the complex building of this nature to assist in creating the right structure. And having worked in a few fairly complex projects, I'm super confident that these days the teams, the structural design teams, are capable of solving most things. Of course, we want to have a common sense approach to it, which is more or less pragmatic, but it doesn't need to be 100% solved, because otherwise, we'll be spending our whole time designing structure in here, which might not be a bad thing, but that's not what I want to focus on now. Okay, now let's go to these and do the same thing in here. So we're going to create a solidify modifier. Let's move myself out so you can see better. Add an array, or not an array, solidify. And we can move that all the way up. So that's going to be the first thing. Offset is going to be positive, and that should go to like 60. Let's just see whether it's going in the right direction or not. Did I select the right thing? Share on core, building mid-grid. Yes, I did. So why is this? Okay, so if I think I know why. Because our face is not filled. So we can do, probably the simplest thing to do is select the face and then fill it. And now those should go in the right direction. There you go. Because there's another way to do it, a screw modifier, which is basically like the extrude modifier. But I think this is pretty good for us. And now let's do the same with the next grid, which is over here. So add solidify. Make sure the face is filled, the first one. Offset is 1, and let's go to something like 70 to create a grid. Great, we got a grid. Nice. Now we have to go back and start subtracting a little bit of that grid, right? And let's go ahead and do that. Yeah, so this setback here is where it gets tricky. And you see, nice try for me, the first grid, but now that I'm looking at it with those kinds of setbacks that are aligned mostly to this side, like this is the heavy setback side, right? So that's where the grid should be aligned more to. So then we have a very nice span on that side. But again, I'm going to leave it as is for now. Let's do a boolean for the grids. So select this grid here, add a boolean modifier, difference, and let's click on the massing. Now sometimes it might not work, and it really depends on the kind of massing. And yes, we are going to have issues here with these setbacks, right? Because that comes out outside of the massing, which we don't want to do. So then we have to find a different way to do that. And usually we can go and specify specific heights, or now I'm just thinking we might not even do it with booleans, but do a similar thing like what we did before, which is with raycast. I'm thinking out loud here as I'm doing this. So I'm going to go first in this example over here because it already has the geometry nodes set up. And now the question is, okay, once we extrude that, we instance that on points. We want to realize those instances. And then we want to raycast only the tops to the massing. So let's add a raycast node, raycast. Then we're going to say set position. I'm not sure whether this is going to work. We'll find out in a second. The target geometry should be our massing. So we drag our masking in here, make sure we select relative. We put this into target geometry over here. And then we want to have only the selection that is hit and then the hit position. But we want to be able to filter that out. So the selection is actually going to come from extrude mesh, and that should be top. And let's see if that works first off, or we have to do some other tricky things. Great. So the top is somehow preserved, even though it passes through that, because the bottom doesn't seem to be changing, just the top. Fantastic. Because now we're going to use this hit position, and we want to mark this so it goes down. First off, the extrusion distance here should be something quite small. Let's try 20 meters. Next, the ray direction of the raycast should be positive. And now, hopefully this works. Hit position. Let's check. Did that work or did it not work? It kind of worked. Not completely, but kind of. Let's isolate this and the massing just to see why it's not completely working. Make sure we see this nice and bright. So it's going up to somewhere. However, it's going up a little too high. And that one is a little bit confused. those ones are also going a little bit too high. Okay, because we set as an offset. Let's get rid of this. Perfect. Nice. And from there on, we can also offset it that it's slightly down, minus 0.5. So it doesn't interact with us. And that should also have done the same thing on our secondary grid, which is over here, and our tertiary grid, which is over here. Man, this is so cool that we're getting to like such a high level of parametricism within here. Of course, here with these kinds of setbacks, we also have this kind of issue where all of the top floor is going to have to cantilever from here. And that cantilever is quite long, right? So they might have to do some kind of transfer structures. Again, I keep saying I won't worry about it, and then I keep trying to explain myself that, guys, I know what I'm doing, but I kind of do. So let's just move this out so it aligns between these two columns over here. And then that's a problem. We've got the column right in the middle in here, and that column is very well aligned. So what we can do is do a slight rotation. So that goes in there, but then circles around this column over here. Columns, gotta love them. Now, is that the right place to go, or should I go more on that side? I think this is pretty good because it comes out to more or less the center of that space. Now, let's make sure the columns here are okay, because we need to adjust this bridge slightly. So we want to rotate it to be something like that. This bridge needs to shrink 4.5. So it doesn't hit these. These are quite dense, so these are like about 6 meters. And that's okay. I think we definitely have the opportunity to shrink the bridges. They're quite generous. Now that bridge, yeah, that comes in the right place. Let's hide that. We have to update our facade now, which is not even showing, and that's okay. So everything is good. Excellent. So now let's continue and do a similar thing over here. So how are we going to do that? So instead of having this extrusion happening in this place, we're going to get rid of it, and we're going to work only with this remove external columns because we already have a geometry node set up that works with all of them. So let's duplicate this. First off, we want to extrude the geometry, extrude mesh over here. And it doesn't matter what height. Some of them extrude funny because they already have a solidify modifier. So we have to be careful with that. So now the two sides, so there's two sides, right? In this building and in this building, this is the aligned 7.5 meter grid. So now we have some kind of extrusion. Let's make it a little bit more, although it doesn't even matter. And we're going to duplicate this raycast over here and say set position. Place that in there. We only want the top faces, so the extrude mesh node gives us that selection opportunity, which is exactly what we did in the previous one. So if we click on only the set position on top, you can see if we drag them, it's only dragging the top. The bottom is staying exactly where it is. So now let's change this to massing 01. Relative distance, that's correct, and hit position is the bit that we want to change, and make sure this is going in the positive direction instead of the negative. And now all of these columns should be reaching to the top. And let's do a slight offset down, so minus 0.5 meters, so it doesn't go completely to the top. Great. Grid is done. Now we haven't extruded our cores yet, so let's go in there and start thinking about our cores in a little bit of a better detail. And for now, I won't worry about floors and exactly where they go. Also, in case you're curious about the stair, definitely check out the previous session, live design session, where we showed why that needs to be about this size over here. Also, I think I might have moved these around a little bit so they're in a better position to give us a little bit more freedom over on this side. There was a pinch point when they were rotated the other way. Again, that was covered in the previous session. Now let's extrude these. Now some of them are duplicate links, some of them are not. So I want to go in there. Let's go into wireframe mode. Select these two. Shift click to select that one. Control L, link object data. And now they should all go up. And how about that side over here? So we need to do the same here. So we've got two lifts. Which one is the lift now here? These are emergency lifts, right? So I think we always need an emergency lift. So that's stair core. What do we call that? Lift. So this here is, I need to look at that into more detail. So let's turn off the massing for a second. So which one has the right color? This one over here. And for some reason, we've got two of those. Probably one should be on that side over here. And then this should be on this side. Yeah, because if we have the shafts, so those are shafts, right? So we don't want to have the shafts exactly in the middle of two vertical elements because we can't really use them after that. Okay, so I'm going to align this just a little bit nicer. Let's move this out that way. And then this one over here. And now we've got our shaft. And this shaft has access to everything that's going on in this area over here. And that's exactly what we want. Great. So, and there's no reason for it to be rotated that way. So it can easily be rotated this way as well. Now these lifts are for emergency use or for servicing or, yeah, all kinds of interesting things. And that shaft can also be rotated. We are taking a little bit of real estate, which is prime real estate, along a window storefront. So in reality, these might come a little bit out somewhere over in this area, in this central area. So we also have windows on that side. Same thing here. We might need to bring those cores out. That's a whole study on its own. But now I'm pretty happy with where these are. So let's link this to those. So Control L, link object data. And now let's extrude our shaft as well. And those seem to be all linked. Great. And now let's extrude our cores. Excellent. How high do they need to go? Let's turn on the massing again, just to see. I think they need to go a little bit higher. So we got 3 elements here. Okay. And now we have an issue. So that setback here doesn't work because the core then is not really working with it. So we either need to move this core to be a little bit further inside or that setback is moved back. So for now, those setbacks are going to be canceled. In here, we can move those setbacks a little bit in that direction. And now I have loco. So you see these are going in all kinds of crazy directions because they're rotated in slightly different axes. And we have a similar situation here, which doesn't quite work. That shaft needs to be on the other side. So that should go somewhere over here. Then we put this over here, and then we rotate this 90 degrees, and we put that over here. Okay. Let's keep moving this in that direction. And I'm just going to try to see what it might look like if we put it somewhere over here. I think that should be okay. Let's lock the massing. And move some of these out. So we need a circulation between here and here. And that's what we're going to do. And in fact, that might make more sense to be rotated this way. And the corridor is going to be, let's turn on that layer. So where's the corridor going to be? So it's going to be somewhere over here. That corridor that I've drawn there is too big, but something along those lines. And then we have a shaft and a lift on this side, and then one on that side. So that's working pretty well for us. Should work much better, and also work a bit better with the setbacks that we've got in there. We might want to move them back and forth. Yeah, now this is the fun and for some people not so fun part of the architectural design, which is making these more tuned adjustments to make sure that everything that we have is working fairly well. Now we have to think about what we've got there. It could be a suite, it could be something else, but the important part is that once we come out of this corridor of the bridge and we have this kind of connection that's linked into there, there should be some kind of corridor that continues in case it needs to. So we might want to move this back that way. So then the corridor is going to be more aligned, because if I go into here, let's just erase some of these and update it. So we've got, well, actually we can take it up from that angle and that goes straight into there. Good, so that's working pretty well. Let's see if we can do some kind of adjustment now on that side here, on this side. So again, we're going to have these come out over here. We should keep a flat straight line as much as possible for the suites and everything that's going on that side. Then we've got our core corridor on the corridor. So this can go over here, right? So we can align it to somewhere over there. And we should align it in such a way that we can still provide a corridor over in between them over here. Then the rotation. So where do we have a little bit of more depth? So we've got more depth over here, and this depth here in the middle, sometimes it might be needed, actually. Yeah, let's adjust this now. Do something like this. Now in some of the upper floors, you can see that we're basically to the edge of there, right? There is no, those windows are not really useful. Like that setup doesn't quite work. So what if we slide this down a little bit? Again, tricky. In fact, even coming out a little bit. But at least we have a bit more, it's along the edge, right? So on this side and on that side, we have more useful space. So I'm pretty happy with this. And now let's adjust. Push these lifts out and put that somewhere over there. And that's the core, right? So should be central. We have it central. We can move on either side of it. The core in here is working perfect as well. So now all these cores should be able to move all the way out. And yes, of course, we have a couple of adjustments that we need to do. And let's go ahead and refresh our facade. So that's aligning better. And you see we have little snippets of core coming out in all those different directions in here. And that floor, again, it's not really working well for us, the top floor, because it's all almost completely covered by core, right? So where does the top floor go? It's over. Oh, okay, it's pretty good, except that corner is actually the one that's taken up by all the core, and I don't think this is showing. So it's over here. That you see that line, that's the line where the core stops. So if that's the situation, we can grab, let's turn this off. We can grab all of this and slide it slightly down. Seem to be selecting unwanted things that are not in the masking layer. Okay. And we know we already have this kind of intersection in there. So how are we going to fix that? We're going to go into here and turn on our booleans intersections. If we expand that, we have another booleans. This is the one that we want to control. So it's this face over here. So if you push this out to somewhere like that. We now just need to click on update the facade. Make sure it's unlocked. Turn off all the booleans. They're hard to see when there's so many of them. Facade 001. Refresh. There you go. Great. Core and shell are done. We might need to extend them a little bit more. So let's turn off the booleans. Make sure we can't select these. And what do we want to select? One of these elements, one of these, and one of these. Okay. And grab all those faces and make sure they go all the way up. In fact, The stairs, do they need to go? Is this going to be an occupiable roof? I'm not sure, because we are also providing quite a bit of interesting space over there, but we usually need to service it. In fact, we definitely need to service it. So yeah, we might need to have those roofs pop out a little bit. Now let's push that shaft. So it aligns with here. Now let's grab these faces, and they should come extra 2.5 meters or so. Cool. So that's the update that we have on our core and shell. So this model now is starting to make a lot more sense. Now the question then is, okay, so how do we take some floor plans of this and make them and visualize them a little bit better? So we can do a couple of things in here. So the easiest one is to do a rendered view that's cropped. So how do we do that? So let's go and create a new camera. So I already have a camera set up, right? So in here, we got these massive cameras. So the problem with axonometric cameras in Blender is that they show up as obnoxiously large. And I don't think the size, the viewport display size, matters. So it doesn't. That's why we have to turn them off. The only thing that matters is the orthographic scale. And as you can see, that's pretty large. Anyways, I'm going to duplicate one of these cameras, go into item, and now let's change the angle rotation to 0. So that's looking completely down. And we know this angle is 15.5 degrees. So that's going to be our top view over here. And we can reduce the scale so we don't have something that's too big beyond our sight. So something like that should work well. Let's make that number a little bit nicer. So 138. All right, so let's see what's going on over here. Okay, so the camera basically sees only nearby vertices. And because we have floors everywhere, you see, if we go near the top, we see the vertices. Or if we go near the bottom, so ground level, we also see them. But in some of the intermediate ones, if you want to see them, we need to add some loop cuts. And we need to add quite a few loop cuts. And I think if we do that, we just leave them where they are, and now try to move the camera up and down. You see they come up. So that's what we need to do here to be able to see our lifts. So that's the way, like these are not replacement of proper floor plans, but they give us a glimpse and an idea of what the plans start to look like. And that's what we want. So we want to do the same for our shafts. Just create a bunch of loop cuts. It doesn't matter exactly where. And the same for here. And we might need some more. There you go. We just want to make sure that they're visible in that plan, which they are now. Great. So now we see those outlines. And if we move our camera around, our plan camera, it shows up on all the floors. Yeah. We have to do a similar thing with the columns if we want to show them up. If you want them to show up. So how do we do that with the columns? We have to basically go and extrude them again. So where have we got our trusty columns here? There's a set over here. So with that one over here, let's go and just isolate it just so I can see it a little bit clearer. So these ones are the ones that are extruded. So once, if they're extruded in here, what we can do, well, there are a couple of ways to do it. One is either subdivide, because there's no way to really add loop cuts in here. We can repeat extrude mesh a number of times. Okay, another useful thing to have a recorded session sometimes instead of a live session is because I looked up how to do this and thought about it a little bit, so I didn't have to waste your time with all that time, but maybe you're interested in. Let me know in the comments. Anyways, so we can add a mesh line. And instead of offset, we say the endpoints. So the endpoint is going to be 70 meters, and the count is where we change the number of subdivisions that we have. So we have something like 70, and those are the mesh points. So we know that each section is 10 meters long. Right, why don't we actually use the... Yeah, let's use offset. So we know we have, let's say 5 meters, even less, 3 meters. Okay, so how do we do this now? So we're going to have these lines here being instanced on points. So instance on points. So this distance here is going to be only 10 meters. Yeah? Rather, no, we want to use the same one. So that's going to be 3 meters. So then we output this mesh to here. And this line is where we have the instances. So if we preview that, it should look exactly the same, right? We have like parts of a column. Next, we want to join the geometry. And we want to make sure the face is not filled, because if the face is filled, we're going to have some issues. So that means we need to use edges, and we need to specify a vector when we use edges. So make sure that this is 1. So now that's all correct. Once we do that, we need to realize the instances and merge by distance. Merge by distance. So now this information is what we want to instance then on the other points. So now we've got something like this. However, the raycast is a little bit broken. So because we're extruding the mesh and then repeating that extruded mesh, the top is not only the top anymore, but it's a number of different tops. So that doesn't quite work anymore. So we have to get rid of it. Instead, we need to filter out the topmost geometry in here. So to do that, let's turn this off here for a second. Okay, so we know the height of those. We know exactly how high they go. So they go around 70 meters. So once we realize the instances, we can say separate geometry. Or we won't do it with separate geometry, but this is, in fact, yeah, let's just do it over here. So I'm going to turn this off for a second. And we're going to use a selection. And we're going to compare the z distance. So compare. And we want greater than. And we're going to use a float. And that float is going to come from our position. So we need a position node. And then we need to separate this into x, y, z's. So this position is coming from the realized instances. So that's coming from each column. And we want the z of the points. So that's going to separate our points. And we put this into here. And we want to take, because we know the actual distance, right? So it's 70 times 3 is what? It's quite a lot. 240. That's too much, isn't it? Let's create this in a smarter way so it calculates it for us. So 30, and we're going to say combine x, y, z. Input here a float value, not a curve. Float value. Float. I think it's just called a value, not a float. Value. There it is. And that is 3. And 3 times 3 is 60. We want probably something like that. We can modify that later. But now that we have these existing as their own values, we can multiply those in here. Multiply to get a very precise value. And that's what we want. So we'll call this top Z height. Okay. So that top Z height, we're going to plug into there. So, and say greater than or equal to. Because we know there has to be a value in there. And we want to do greater than or equal to. So now if we drag them, you see we're dragging only the top bits. Nothing else. Great. So we've got the right ones now. Let's reset this offset. And this hit position now, it should work with us. We have too many subdivisions. So we can turn this down quite a bit. Hold on a second here. Something is not quite working right. Because that shouldn't be going up or down like that. Let's see now if we go and turn on the massing. It should be visible. Creaky door. Okay. So what's going on here? So these are snapping in the right position. The Z height, that should be correct. We might want to adjust that by just subtracting a little bit from it. So let's add another math note in here and say subtract. And we want to subtract a small value like 0.5. So that should give us a slightly better position. And yeah, I think we have to go down because we still might have too many floors in here. And yes, that's where the issues are coming. You see, those are too high. So let's bring this down a little bit more by reducing the number of subdivisions until we stop having those kinds of funky situations happening here. Okay. So that's working pretty well. However, now, whatever is that greatest height, we might have too much of it. Okay, so I forgot to plug these into here. So that integer should have gone in there. And that's where the issues were coming from. So once we have that in there, now it should work a little better for us. Okay. And how did I figure that out? So I selected only the selection to see what was actually hitting it and what wasn't. So now we should have all of these in the right place and then just go minus 0.5. Great. And we should also start to see them. So we might need to adjust that camera a little bit. Okay. So they're not solid and that's why we might not be seeing them. So we actually need to make those solids. So if we go back in shell and core, select these columns over here. And we want to cap them. So the easiest way then to cap them is to do a slightly different way, again, of what we've done here. And the beauty of doing these semi-live, right? This is still not quite live, but not quite recorded because I haven't practiced it. I'm doing it as we go because I want to give you the raw experience in here. So we're not going to do a mesh circle. We're not going to do extrude mesh. We're not going to do any of that. So let's just go in here and let's do a curve circle. Curve circle. And then we're going to do a curve line, and then we're going to say curve to mesh. So we're going to sweep that circle along that line. So this is our curve, and this is our profile curve. And in here we have this lovely option, which is fill caps. So all of that is going to simplify our setup over here. However, I'm just thinking now, it's still not giving us the right way, because we're not going to have a curved top and a curved end, even if we do a small section. We can though change, yes, that's what we can do. We can change the dimension of this curve here. So we'll make it the overall height first. So we can say something like, because we're aware that we're going to have setbacks, so something like 20 meters, and then we can go in there and say resample curve and change the number to something like 30. So now that curve has been subdivided a bunch of different ways. Now let's make sure that these are matching 0.15 fill caps. So this is going to replace all of this over here. That should become much simpler into there. And the subtract, we're going to use this 20-meter height. So we can drag this out in a similar way. So let's duplicate these over here and connect it and say that this is 20. So then we can drag this out. Great. So now I'm going to delete all of this information over here. Excellent. It's a little bit cleaner as well, isn't it? So fill caps. Excellent. And now that's going to be our instance. And if we see that, we still have a bit of a challenge, which is to say that we want to use that value here for our height. Let's just see now what's happening. Yes. So these, the curves, that should work. Curve and profile curve. Sometimes they want to go along the Y direction instead of the Z direction. I suspect this is what might be happening over here. So let's try that. Yeah. So I don't know why, but with curves, the Y direction is the up direction and the Z is not. All right. I'm not sure exactly why it is, but that's how it is. Okay. Now they're going the opposite way of the way that we want to. So we can add a math note in there. Math note, plug it in and say multiply times -1. So they go up. Excellent. Hopefully now it's working all in the right ways. Excellent. Finally. So that should also come up nice and clean. Still not showing up. All right. Should come up nice and clean in our attempt at having a floor plan of some way that's kind of useful for us. Now there are different ways to do this floor plan with Blender BIM, and I'm a little bit reluctant to try Blender BIM because it's a whole different paradigm than working with Blender natively. And you know it's got its own arrays, and instead of geometry nodes, we have to work with Sverchalk. So I love what they're doing. I absolutely love what Dion Malt is doing, and we talk about it. I pay attention to what they're showing. It's just a little bit different than my typical concept design process. And what I would really love to have is take this and somehow convert it into a BIM model without losing its parametric setup within Blender. But I'm not sure how to do that yet. Anyways, why I mentioned that? Because they also have floor plans. They have really nice floor plans if things are tagged properly. Like we would tag this as a wall, we would tag this as a floor, and so on. Right, so our floors are not there. Option B then. Option A is a failure, and so we'll do it the old school way, which is a little bit slower and a bit more bothersome, which is with, yet again, booleans. However, I am thinking that there might be a faster way to do it with booleans. So instead of trying to subtract all of this with booleans, we might do, because the facade is going to be really slow, we don't want to subtract all this facade. That's going to take forever to do. So instead of that, what we can do is subtract our original massing from this boolean, so it appears like our building is much, much smaller, and then we should be able to grab a nice section cut in there. So that's a little bit of a cheeky, like, shortcut way that I'm thinking might work. So let's first rotate this. So it takes up our site over here. I feel like I'm always warming up in these sessions a little bit. So it takes a little bit of time to like get into it like properly. Once I do, you know, I feel like my energy is a little bit higher as well. I feel like I can explain things a bit better, but that's no different than like starting work at 9 a.m., right? 9 a.m., you're all a bit groggy. I don't know about you. I am a little bit groggy. I'm like, ugh, what's going on today? What do I need to do? How do I handle that? And then, you know, in an hour or so or time, then it starts to get a little bit easier. Okay, so how shall we do this? Subtract or intersect? Doesn't matter really. Let's just do it for clarity's sake as a subtract. So we know that we're getting rid of everything that's on top of there. And now we're going to do the magic with, where are we? Our massing. So here's our massing, and onto it, we're going to add a new boolean. So add boolean. We have this glasses bridge. Let's see what this does. So bool bridges greater than set. Okay, so this is materials. So glass bridge, we should name that better. Materials. So as you can see, even in between the sessions, we tend to forget things. So it's very important to label things as clearly as possible, even if it's something as small as that. So that's okay. That doesn't change our setup in any way. So difference. So let's click on that. Select this. And that should do it. Except we have to always manually refresh. And we can't select it. Our floors because of the way that they're done. And that works pretty well. And if we remove that, it's pretty performative. So that should give us a pretty clean floor plan, except the columns. Oh, the bloody columns are a little bit higher. I think we can make it work. We just have to position our camera in a slightly higher place. So if the camera is, let's say, here. Total cheat in a way, isn't it? Do they intersect? There's a slight. Am I correct? Maybe I'm not correct because this is coming up. So let's select these columns, and that offset, let's make it 2 meters. There you go. That gives us an intersection in there. These should finally be able to show up on our floor plans, and they're nowhere to be found. Why are you nowhere to be found? Let's make sure that camera is in the right position. It is. It's intersecting in there. Why in heaven's name can't we see our floors? Okay, we see them. Excellent. They are there. We see those. We see those. We need to see these now here as well. So we need to repeat that process for here. Right. So curved line. So 2 meters. And now all of our lovely columns should be showing up. No idea why they're not showing up. Oh, I know. We need to hide this because if we don't hide it, it shows up and everything is actually intersecting with it. So that cube should be called bool sections, bool plans, bool what? Bool plans? Bool plans or sections, really? Okay, so, whoops. Got a bit of a wind draft here, so crazy door smash behind me. Why are these columns not showing up? Aha, they're not filled up, so we need to fill them up. Why are they not filled up? Curve to mesh, fill caps. That should all be working, but I can see, are they filled up? Oh. See, this is something I never do, and I guess there's a bit of a struggle with that. Since I don't do it, then it's having a bit of problems. I think the way to solve that now is to bring that up. And we should see them, all of them. There's no reason why they shouldn't come up unless our camera crop, I made it quite small. Let's make it a little bit larger so we see it. Why in heaven's name are these columns not showing up? Wonder if you have to do something with geometry nodes. Because the non-geometry nodes ones are showing up, but the geometry nodes ones are not. So there must be something with the shading. Not exactly sure what. Let's just do a test run and render this out to see what it looks like. Save. Now render that scene and sort it out. So again, these are coming up, but yeah, those ones are, well, we see something along the lines. Is it just the material that's matching? Maybe we need to give them a different material. Then I'm not sure why everything, well, yes, everything else is black because we're intersecting with it. So we can still move this camera up. In fact, we can use like the vector of the camera, now that I'm thinking of it, to have like as a cut plane for our geometry. All kinds of interesting things we can do. So those plans are still not showing up. I think they must be hollow. They are hollow. That is the problem. Why are they hollow though? We've got fill caps on. We're sampling the curve. Let's check without set position and isolate them and look through them. So they shouldn't be hollow now. It's hard to tell whether it's hollow or not. Let's go to top view. So in top view, they would disappear, they're hollow. And yes, they are hollow. Which doesn't make a lot of sense to me because they shouldn't be, because we've set their curve as the profile curve. Let's try a really small distance just so it's easier to see for us. 2 meters, even more, half a meter. And why is this not working? It might need to be, why is that not working? I guess it needs something that's planar. And because we're not dealing with something that's planar, that's where it's having a bit of an issue. Okay, so we need to find different ways to cap that. So I think I know the way. So we're not going to do this automatically. We're just going to use this curve circle here. We're going to make it a curve. We're going to make it a mesh. Or in fact, we can use a mesh circle just so it's filled. It's going to make it a little bit easier. Mesh circle. Same settings. We're going to put this all the way on top. So where we moved the other bit. So it's going to take this here as the vector, right? Whatever value we say. So let's rename this and say Z distance. Okay. So then we're going to transform that, or we can even use set position for the whole geometry. And the position is going to be, or rather we can do an offset. So the offset is going to be this right here. So that's going to be on top now. That's going to be in the right place. So then all we need to do is join the geometry. So between this and this. And in fact, let's join also the original one. And then merge by distance. So we make sure all the vertices are merged. And now those should technically be filled, except we haven't specified. So field type and gone. So we've got the top and the bottom. Right. So the offset in here is along the Y, because there's this strange thing which I cannot explain why the curves are working that way, but I know they do. So let's duplicate this, and this should be our Z value for this curve here. I'm going to add a a little helper, so that doesn't intersect. And now if we do offset, now that's in the right place. So that should all be good now. So let's double check the merge by distance is working. So here we have 1024 vertices. And here we have 960. Great. So that's all done. So now that should work for us. So finally, I'm really hoping our plan is good to go. So let's render something out just to double, triple, quadruple make sure. And gosh, they're still not showing up. Right. So why is this still not showing up? Getting very tricky over here. There, inherent bugs. We're trying to do architecture in the wrong software, right? That's what people say all the time. It's like, why are you wasting your time with Blender? Why not? You know, it's got such a good way to use it if you know how to use it for most things. Not 100% of the things, but most things. For what I use it, it's wonderful 90% of the time. Right. I know exactly what's going on. Our columns are 0.5 meter tall. So let's make them a little bit more generous now. So there you go. And we also have you see our shading needs a little bit of work. So is it flat? Is it not flat? So it's a little bit confused with what kind of shading we have. So set shade. And for now, let's do it just with completely flat. Camera. All right. We finally see them everywhere. Excellent. So we can take, we can now do a render that shows this a little bit better. So F12 again, just do a cheeky render, sanity check. We've got a hole in the floor, so we should fix that by putting something there. In fact, all of these are coming up as floors. That's pretty interesting, I suppose, isn't it? Like we're only seeing, because those are negatives, so we're only seeing like the actual volume. Okay, I'll buy that for now. I'm not sure why we see that there's a hole, to be honest. Really don't understand that. Why are we subtracting from there? That's selected. Look at how interesting this is now. So yeah, booleans are working pretty well like at the moment because we're only using them with the base massing, right? We're not using it with everything else. And then we just have to click refresh on this for them to show up correctly. Okay. So let's try rendering this out again. And I'm just curious. So we used to have something there on the floor, like the footprint. I wonder what happened to it. So the footprint is still there. It might be that our camera needs to reach further. Let's see this camera now. That's coming true. If we move that boolean around, that impacted. No, there's something else that's happening. So there's a hole in the floor, and I don't understand why we have that hole in the floor where here we don't. Aha. I think I see it. Okay, so basically where we have this black hole is because we have two planes that are exactly intersecting with each other. So if we go ahead and hide this footprint, then it should show up exactly as it should. We see our bridge somewhere lurking on top, so we might want to hide it in there. But for now, let's render this out. Okay, and yeah, at this point we know where the walls are, so we can go ahead and start to put those in there, which we're going to intersect once again with our massing. So that massing is quite important, as you see, because it makes everything fairly low res, and it allows us to be a little bit more free with the way that we approach this. So now if we go to our floor plan, and we're going to start with 0 or somewhere near 0 and start creating planes, start creating walls. And the walls are just going to be edges. So let's go ahead and delete those edges. Now let's rotate this 15.5 degrees in the negative direction so that aligns better with our floor plates. So now we're going to do the upper floor. So we're not going to do the lower floor yet, but we're going to start doing the upper floors. And let's start over here. So we have a column grid. So we're going to use that column grid there for what we need, and we know the rotation of this, which is rotate 30.5 in the negative direction. I thought that's what it was, but maybe not. So let's see now. It should be about minus, oh, I know why, because before I started with the perpendicular direction, so minus 52.5. So we kind of have it. Now we're just going to put here minus 52.5 degrees. Great. So that's going to be our perpendicular direction here. And why is that moving in the local? Okay, yeah, because this is local, but we want to combine these two. So the easiest way to do is go into the wireframe mode, where we can select them and Control J to join. And now the local is a bit messed up, but we can go to normal. Or we can even add a new direction here. So that's what we'll do, because we'll be using this one quite a bit. So let's just call this one edge. So we can much easier drag into here to come to the right place. Great. And we're going to, in fact, let's do it to over here. And now extrude. So that comes to that edge, to the edge of where our bridge is. That corridor is a very nice, very grand corridor, almost too nice, isn't it? And now let's duplicate this to somewhere over here and continue to create our walls here. So these are, we're only doing the suites at this point. We're not going to worry too much about everything else. And now let's duplicate this edge, rotate it 90 degrees. So we can start creating the facade here, because that's going to be essentially a suite as well, isn't it? So we know we can do this into there. And this is the normal direction. So we're going to do the same thing that we did before. We can intersect those edges here. Okay, so that's working. Well, that's a pretty strange one, isn't it? So we're going to duplicate this. So we moved the column a little bit now, and we shrunk it to 4 meters so we can have a less generous corridor, because I think it was getting a little bit too generous here. To something like that. It's still quite generous, but I think that works a little bit better. And now we can go on the other side, and let's duplicate this edge to maybe somewhere over here. Now those people, they might need to have a secondary axis. So that axis might be too far away for them. I think it's okay. I think it might be okay. Actually, it's these people here that are going to have a bit of a problem, aren't they? So we can push this back, because that's not going to extend that far to somewhere over here. So let's select this. And again, these are suites, right? So the internal subdivision, we're not going to worry too much about, because that could be whatever it needs to be. Now let's make sure these are aligned. Now the only thing I'm worried about is from this distance to there, that should be okay. From there to there, that should be fairly okay. Great. And now let's intersect these two edges over here. So tiny cat and intersect selection edges. And then let's get rid of these vertices over here. And what do we need over here now? So we need a couple of extra. So first off, Let's move these so they're aligned with that edge, and they should align with each other a little bit better. Okay, now they're all completely aligned. And now let's align here. And there's probably nothing that's stopping us from moving these. Well, there is. Let's just check over here by going to the massing first, or we can do it. Let's move this bool plans that we've got. I don't know why we're not seeing that here. I'm bedazzled by it. We usually see it unless they fix some kind of bug in between where those booleans stopped appearing in there. Could be. I have to test it in a new file to confirm that. Because that's great. I don't see that when it's rendered. Let's see if I turn on render, whether it will pop up. Still not showing up. What about in this view if it's rendered? Yeah, it's coming up here. So I must have turned something off with collections to not see that. It's in cameras. That's it. Cool. Yeah, because it's in cameras, I don't see it. Anyways, let's move that way up so we see our whole collection and turn that off. Refresh our facade again. Turn off our lovely booleans as much as I like them. They get in the way. That would be a nice bug to fix. I don't know if it's a bug. I think it's a bug. I don't know if the Blender Institute would call it, if the developers would call it a bug. So let's refresh that facade now. So we've got our whole thing in there. Now let's go back and see. Yep, that works pretty well. Okay. It's starting to make more and more sense. As a building. As a massing, not yet. And we're really getting to a point. It's gotten a little brighter since I started recording, so I had to turn down the camera settings here a little bit, so I'm not terribly, well, now I'm maybe too dark. Let's see now. There you go. So yeah, the building is really starting to make sense, isn't it? Okay, so now we can push that so it's nice and flush here with the edge. That works well with our staircase. We might want to swap like that stair, and here it might even be rotated. I think that's okay for now. The important part is it doesn't intersect with anything else that we've got on top here. And because of this awkward spacing, we might need to push this a little bit further out and just create another one over here. So we have a better understanding of how the separate suites can work. So that's all set. Now let's continue. And I am going to, should we do it in the same one? I think so. Let's do it all in the same model here. So let's create another wall. And then we're gonna, so we're doing this once, right? And then we're going to do it another time with the further separation. So with the internal walls. So let's delete this edge and find one. Well, actually in this case, they all became aligned along that edge. That's okay. So I'll show you how we can cancel that out. So let's go to local. And if we make this a Z, now that's better aligned over here. And what do we want to do now? So let's create our suites over here. And that corridor is very generous, and we can turn off or at least make the opacity of these nodes a little bit less. There you go. So these should all be in one line, so that's working fairly well for us. And we can grab a little bit more by doing something that comes to this edge. Let's duplicate that edge over here. That's more generous here than it needs to be because that's the waiting area. So we don't need to be as generous once we get closer to the corridor because only half the people are going to go in that direction, even less than half, right? So then we go over here and we have to think now. So we should have doors that enter in there, and that depth, you know, that's a suite depth. So we don't need to worry about any more internal corridors over here. This here could be a suite. So we can have some kind of doors situation in there. So you can enter either on one side or on the other side. And we can do something like that in here. So we've got an edge that's aligned to here, an edge that's aligned to there. Let's duplicate this, rotate it 90 degrees, snap it along that edge, and then like that, and move that. So we're extending the edges quite far out because we're going to snap to them in a slightly different way once we're basically we're going to extrude, not extrude them, boolean them with the massing. So that massing is like our secret superpower. Is it superpower? I don't know. Now this spacing here is very large. Let's see again, what is it? So that is 3 meters. So that's a very generous distance for that kind of corridor, but that's okay because here it's not only about the corridor, right? We're trying to create a very interesting position. So we want these people to experience the waterfall when they're inside of there. So that's what we want to do. So I think that's quite important to keep in there. Okay, so let's snap this into there. So we got these walls in here. So let's continue. So I'm going to duplicate that wall over here and rotate it 90 degrees. Snap it to that point. And then it needs to come to wherever this bridge is. We want to be a little bit outside of the bridge. So the massing has an easier time when we're intersecting those walls. Great, so that's that edge over here. And let's duplicate that on this side. And so that's going to be a little bit different now, isn't it? So we need to come to somewhere like that. Not 100% precise, right? And that's okay. So that's pretty good. So we got the walls here. We've got the walls there. And let's continue. So let's create our walls over here. So let's duplicate this, scale it a little bit more. And first let's rotate it so it's in a position that makes sense. Something like this. I think we have the booleans on, so I'm going to turn it off. But before I do that, let's make sure that this is the right angle. Okay. And now let's turn off booleans. Great. And so that's the edge that we're working with here. So we want to save that edge in there as well. So first off, let's go to normal and now add plus. So we know that that's an important edge. And let's go now to somewhere outside of this column grid line here. That's an important one because we don't want the columns to be inside of the corridor, whereas inside of the suites, we can position that a little bit better. Okay, so we've got that corridor. Now let's duplicate this, Shift D to 3 meters. So we've got our corridor here. And as you can see, we need to do an adjustment of our core because that core at the moment doesn't work that well. And we've pushed it back, so it's not going to intersect. So we don't need to worry too much about that. And we want to rotate it so it faces that direction better. We're still going to have that kind of offset there. That's a little bit challenging. So we can move that. However, that edge, it doesn't become very useful, does it? That's more or less lost space. So then where else can we put it? We can put the core here, and we might even extend that edge a little bit further out. So then that might make more sense. Or we can have it split, right? So we can have something happening on one side, and then these shafts are coming onto the other side. Now we just have to make sure that, okay, this is shaft and this is lift. Yeah, basically we need to have one shaft that doesn't have any vertical circulation and can service this core, and then the same on this side. That's pretty good. So let's shift these that way, and we're going to move that edge a little bit down as well. So you can see they're not completely rotated the right way. So we need to go back now into here, and that's going to be the gap. That's going to be the spacing. So that gets also a little bit tricky now, right? So is that the best place to place them, or is it here? It might be there. Again, not ideal because we're eating into like the corner space, but I think that works fairly okay. That shaft though, it's blocking what we've got going on that side, but we still want to keep it together with the core. We don't want the core to be overtaking a lot of the position. So let's move it over here and shift the core slightly down. We have to make sure that we have the maximum distance allowed from all the other places. I think we do, so we're in a good position. So okay, we've got our core moved. We have our base corridor here. Oh no, I forgot that we have all that whole section over there. Yeah, so that's too far. So let's slide this over on the other side. That should be better. Somewhere over here. On the top floors though, again, we have a very funny distance here. And that's part of the architecture design, right? It's like this amazing 3D puzzle that we have to solve between all the constraints that we've got going on to make sure that whatever we're proposing works well. Now, is that the right distance? I'm not sure either. Is that getting too far? It might be. So that stair, that emergency stair, the best position for it might be somewhere over here. So let's try sliding this around as well once again. So these two edges come down to somewhere over here and position that stair to somewhere over there. Now let's just do a little sanity check. So if I draw something, so we are over here, that's the distance, or we're over here. That's about midway spent. So that's good. That's what we want. Let's put these back now to over there. And yeah, we're gonna push that corner slightly over. Again, it's a little bit of a shame that we're losing the space for some of the mezzanine levels, because mezzanines are always really, really nice. So we want to have that a 360-degree view into what's going on into that area. What do we have that's interesting here? So you have a bit of life. So you have that bridge that comes up. That's quite nice. That's a little bit of a square. There's sometimes these events in these floating platforms that are quite nice, but you still see around them on the other sides. Frankly, that should come over here, because on that side, we want that to be blocked, but we also want to have a step back, even probably more generous step back for the residents that are just next door. Okay, so and then we're going to put that over here. Not ideal, not terribly happy with that, but I think for now that's the setup, the layout that makes the most sense. And now let's start to push these inwards. Duplicate that. Let's go to local orientation, scale it along the Z, start from this edge, and now let's move to somewhere over here. Okay. Duplicate this 3 meters, and let's connect those, and let's go back from there 5 meters in the negative direction. These edges here, we're going to intersect the same way that we were intersecting them before. And in here, we need to subdivide this twice and slide these here and here. I wonder if I can, yeah, I know I can actually. Well, was it going to be along, yeah, so it's got to be along this edge. And now we extrude that. I don't think it's going to be that perpendicular. It's going to have a slight angle unless we move everything over. So what if we slide those two over a little bit? That becomes pretty perpendicular. Although that perpendicularity is somehow not completely aligned with our columns here. There's a slight edge to it. How did that happen? Let's look at this. Yeah, we need to rotate everything ever so slightly because it's not exactly aligned with our columns over here. With the column grid. By the way, in Blender 4, we're going to have transforms with a base point. So that's going to be really nice. Something that's desperately missing in Blender for architectural design, for any kind of design really, where you need to not only be artistic about it, like I'm being right now, but also a bit more precise about it as well. So that angle is the same as that angle. So what do we want to grab here? Let's grab this edge. Go back to, why don't I make this bigger? Go back to local and duplicate it. In fact, let's do this, 3 meters. Okay. Create a face. So that's going to be one edge. Snap these back. Select this whole thing, rotate it 90 degrees. So that should be aligned to our front, which is over here. And now let's push this back to 7 meters. Something like this. Make sure it's not interacting with too many columns. Like that. That's pretty good. Now let's grab these over here. Go back to edge. I wish there was a shortcut for that. I wonder if there is. Which one would it be? Here. It would have to come as parents, but it's not. That would be pretty cool. That would be really, really cool. Okay, so now let's grab these edges here. In fact, let's isolate our selection and turn off the nodes. And make the background light so we can see this better. There you go. It's a bit easier on the eyes, I hope. So tiny cat, VTX, intersected edges. Same here. Intersect selected edges. Get rid of these elements. And let's do the same here. So that one needs to extend a little bit. And we're going to do this trick. So intersect selected edges. And now these two here. So tiny cat, intersect selected edges. So we can get rid of these. We can get rid of these. So these are our walls here, aren't they? That's all the walls that we've got. Excellent. So that's the one level. That's the first level, let's say. Those are the thicker ones. But we can go in there now and let's add some intermediate levels because that's going to make the space a little bit richer, the massing a little bit easier to understand. And if you've been to a hospital, you know that suites get adjusted all the time. They need to be flexible. So these are the internal walls now, and they can vary. They don't even need to be the same on every floor. We're going to make them the same in every floor for now because that's just going to be easier for us. But sometimes we've got an edge that's doing that. You know, that's the internal suite in here. And now let's rotate this 90 degrees. And these start to be individual walls, individual offices. You know, they can be all kinds of different things here. Sometimes we have some kind of lobby as well, like a waiting lobby. This could be like a doctor's office. And now this here could be a room. And then let's duplicate that edge and start inputting some more rooms. This one here might want to, I think that's fine. I think that's okay. Something like that. Notice that like whatever is inside of the corridors, well, yeah, why don't we snap it nicely? We can do that. It doesn't take too much more effort. It's going to make, if we ever take plans, a little bit nicer. Okay. That's going along the local. And let's extrude that. And then continue to extrude. And I'm going to extrude this line over here as well. And yeah, we've got a funny place, funny space. It's inevitable when you have some angles, but I think that's perfectly fine. I'm just making these a bit random at the moment, just trying to do them quickly, but with enough understanding that they give us a bit more depth of what's going on here. So let's grab this and extrude that way. We're going to have somewhere in here like a lobby area. Reception area. Which one should it be? Let's make it over here. And let's get rid of this wall. And that one can come to there. Let's make sure this is nicely snapped. It's not going to be all the way because that's still quite generous, but it might come from somewhere to over here. And yeah, that's a lot of space, isn't it? I think that's good. That's for, your MRI and radio scans and, patient offices and storage, loads of storage. It could be like a nursing station in there. A lot of possible functionalities. Let's go now and carry on with the rest of the walls. Yeah, I think at this point, I'm going to pause this and I'm going to show you the result, which is carrying on the exact same way as what we've got here. So see you in a few minutes. Okay, so 10 minutes later, we're almost done. We have this layout more or less done. I want to plug in for just some of the last parts, just so you have a better understanding of how I modified things in here. So it's all about really duplicating. So hotkeys here are really essential because they allow us to work much faster of being able to snap onto things. Right now I have my what is it called? Edge snaps selected. So I'm just snapping to edges and extruding and extruding and extruding. And then making layouts that I know more or less make sense, but not completely, right? Because this is the bread and butter of planner architects, space planning architects. And that's a whole, to get this plan right, I mean, that's the most important thing. You would have somebody that's working just on the plans, somebody else that's working on the facade, and, maybe a third person that's working on, what else would they be working on? There's a lot of things in hospitals to work on. Some code compliance, but code compliance goes with space planning. So they would be doing a lot of that in there as well. And yeah, it's just really about getting this and making it in a way where it makes sense. As much as possible at this stage, right? Because it's not going to completely make sense by just tying these. I don't even know what these departments are, right? So that's an important consideration to have when we're doing plans, isn't it? Right. So and then all the external edges, they just come out a very specific distance. Now let's select that edge and just drag them out and then duplicate this. Let's say, what distance is that? 4 meters. I might be making these rooms too small now, I'm realizing. Oh well. Now let's do Shift D duplicate. And now because of the setbacks, a lot of these rooms, like the upper floors, they would have different layouts, right? The corridors will shrink and yeah, they require their own sort of understanding of how those floors work. Okay, we have some kind of funky spaces in here. Maybe we should align that so it looks a little bit more purposeful. We have some utility rooms, lots of closets, like lots of... Let's make sure this is on the right edge and extrude it, snap it. And I think this layout is pretty good. Oh, that corridor is way smaller than that corridor there, isn't it? So the tricky bit is though that I didn't really align anything to it. So yeah, it's going to be a little bit hard. Let's just leave it as is for now. Let's say that our layout is pretty much done here. So now we're going to push this to our floor, the first one that doesn't set back, which I believe starts from 8 meters in our case here. right? And then let's make these walls solid and then intersect, and we're going to do a boolean with them. So we can do this completely with modifiers, by the way. So we first go to add modifier, and we do screw. Screw modifier took me a long time to understand how it works. It's essentially a revolve modifier. If we change the angle to 0, iterations is fine, screw, and now we extrude it. You see, it's just an extrusion, basically, isn't it? That's step number 1, which is just, they don't have a thickness yet. And now we can do a solidify, and everything should get a thickness. And we want to shade all to smooth. And let's change this offset to 0 and do something like 0.15 for the walls. That's our walls set up here. And now we can add a boolean. Let's move myself out of the way. So add a boolean. And we want to intersect with our massing. That might take a while. And let's see if fast would work a little bit better or not. Fast. Yeah, so that boolean is not terribly happy here. Oh, it worked. For the most part. There's some challenges, like at the bottom. So sometimes what I do is have something like 7.95, just so things snap a little bit better. And you see that improved most of the things, except that odd wall that we have in there. Let's see what's going on with it. So that must be getting too close to an edge also. So if we try to move that slightly out or slightly in, that sometimes helps. And also having more subdivisions helps. So here in the screw modifier, the steps, we can try to change that to something like 32. Sometimes that helps, but not always, as you can see here. So what else can we do then? It's just hitting something on a funny angle where it's not really happy. Usually it's like exactly at a point where it might have an intersection. So let's go and try to modify, I think, was it this wall? First off, if we move that further in, that's far enough from an edge, so it shouldn't be too much of a problem. But yes, booleans sometimes do have a mind of their own. Let's see now if that worked. There you go. Just a slight tweak, slight move. Fix that. So now we got walls. Our columns are sticking out because we were doing this for a floor plan. So if we cancel everything out, and now if we go in there and do a preview, we should have something with interior walls. I think the material that I'm using is too much of glass. Let's see, facade. Not floors, not massing, facade. And I guess I'm assigning the material here. Where am I assigning the material here? Extrude mesh. Tessellate. Is this the right one? Yep, that's the right one. Actually, those might be... Oh, okay. Yes, so that's a panel. So we're using the panel. Let's find the panel. And now it has the glass. Let's go to here. The object. And we can make this transparent. So this wasn't transparent before, but now it can be transparent because we actually see through it. We can turn off the massing. The massing is not needed. So now we should be able to actually start to peek inside and realize that, okay, this is not, wow, these are too tight. I should have done some numbers to make sure that those massings work, right? Like those walls are all correct. Because some of them are way too tight. Anyways, this is a good point to stop. Now, in the next session, is where we're going to start getting like really interesting again. And that is, we're going to sketch on top of this. And, this is our base case scenario at the moment. This is what we are starting with. This is something that looks okay as it is now. We understand that it works. In fact, I really want to go in there. Let's go in there. Where are we? It's quite dark. So let's go to one of these modes here. And I just want to see through one of the panels. Where are we now? Oh, it's hard to orient myself. Let's make the camera a little bit smaller. Maybe like 30 degrees. I want to get inside and see the from the lifts. I want to see the water. Okay, you know what? This is tricky. So let's position a camera. Let's position a proper camera. That's helpful because that will stay as it is. So where should the camera go? Somewhere right over here. So you come out the lift. You're standing over here, somewhere in the building. Should be anywhere in the building, but let's go a little bit higher, like there. And now let's make this the active camera. And we don't see much. So first off, we need lights in there. So let's just go to EV preview. What do we see in there? Yeah, we're starting to see it. Cool. And if we move a little bit closer, and I think I need to move that camera slightly down, and this one has a shift axis, which I don't want now. That axis should not be shifted. There is way too much ambient occlusion for EV, so we can go and reduce that to like 5 meters. There you go. We're starting to see that. I feel like some of the walls are not going there though. Where are we? They should be. Yeah, they are. That's strange that I don't see the walls here. Even though they appear to be there. It's probably on the wrong layer again. Let's see. Are these? Yes, these are our walls. Okay. So that should be part of our shell and core. There you go. Now we see our walls. They're not perfectly aligned, so we just need to align those. So the idea is that from there, let's give that glass material a little bit of transparency. Massing. Panel. Glass, and that's an EV setting only. So once we have EV, if we go to the material and blend mode, alpha blend, shadow mode, none. When we have glass. And now you see that we see through, and we see a little bit of that waterfall in there. And that's really what I want to do, is like really accent that kind of waterfall experience into it. Of course, like once we start doing interior shots, we have to worry about like what the interior space looks, what does this perimeter look, do a little bit of work on that. But I just want to have like some kind of understanding of the experience of that space. Great. So mission accomplished for this session. And in the next session, we're going to start to present this work, right? So put a package together. We're going to make like a really nice package of the work that we have so far. So it's essentially like a conceptual package. And after that point, we're going to go back and have loads and loads of fun with making this maybe a little bit more parametric, maybe a little bit more interesting, and let's say less rectilinear. So thinking about the facade conceptually, maybe it grows from the waterfall. There's going to be some kind of super nice connection in there to have like some things to build on top of the work that we've done so far. If you're interested to know a little bit more about this, the files are on Patreon. So you can always check him out and also become a patron if you'd like to support this work. And so you've got all the sessions in here. We've got some behind the scenes footage in there. You can also get the files in there. So there's quite a few benefits, but most importantly, it allows me to do more of this work. So your help is much appreciated. And if you want to know a little bit more in depth about some of the workflows that we're showing in here, make sure you check out academy.uhstudio.com. And there's quite a few courses with a few more coming up. especially one with geometry nodes and working in a fairly similar way to what we're working in here, helping us work a bit more smart, a bit smarter, with not terribly complex geometry and terribly complex geometry node setup, but just little snippets that allow everything to stay a bit more parametric and easier to adjust and get to the right point quicker through better iterations. So great. That's where we're ending up now. So we'll see you again this week in a few more days. So have a good day, everybody. Bye bye.